is going to be recorded. If you have any objections, you may disconnect. Please stand by for the conference to begin. Thank you.
Good afternoon, and welcome to NASA's What's on Board briefing for the agency's Commercial Lunar Payload Services, or CLPS, initiative. My name is Nilofer Ramji with NASA's Office of Communications, and today's briefing will preview one of the first CLPS flights, Astrobotic's Peregrine Mission 1. Astrobotic is scheduled to launch aboard ULA's Vulcan rocket no earlier than December 24, 2023. This briefing will address the significance of the CLPS flight and highlight the NASA-provided payloads flying aboard Astrobotic's Peregrine lunar lander. Our briefers today are Joel Kearns, Deputy Associate Administrator for Exploration with NASA's Science Mission Directorate, Ryan Watkins, Program Scientist with NASA's Science Mission Directorate, Chris Culbert, Program Manager with NASA's Commercial Lunar Payload Services, John Thornton, CEO for Astrobotic, and Haley Moosbrugger, Payload Manager with Astrobotic. First, we'll start with some initial remarks from each of our briefers before opening it up for questions. We'll be taking questions on the line, so if you've joined us today, please press *1 to add your name to our queue to ask a question. We'll now begin with opening remarks from Joel Kearns. Joel?
Thank you. It's really exciting to kick off a new American adventure on the moon starting this December. As part of Artemis, robotic spacecraft will conduct important scientific studies in the near future and then later in parallel with exploration by astronauts on the moon. Now, NASA continues to be very successful with robotic scientific missions in space. You've probably seen Perseverance roving on Mars or the deployment of the James Webb Space Telescope. Over decades and over careers of work, we've developed what we consider our practices for mission success. For example, we spend the effort to ask ourselves before we launch, what else could we do to make this successful? Now, about 5 years ago, NASA decided to use a different and we think innovative approach for in the future to conduct scientific work on the surface of the moon. We would go out and seek commercial services from American companies rather than NASA owning the mission, developing a custom spacecraft, and operating it ourselves. This is part of our effort to use commercial services and public-private partnerships where we think those are appropriate. Instead of flying or designing NASA lunar landers, we're contracting with American companies to take our scientific experiments, engineering tests, and technology demonstrations from the Earth to the moon, soft land them on the moon, and then send our scientific and engineering data back to Earth. This is a deliberate change. We think it's innovative. It's to leverage the innovation and the entrepreneurship of American private industry to accomplish these public goals. If there are American companies providing a delivery service to the moon, we feel that the cost of buying a service should be much less than NASA owning a custom end-to-end mission. This would increase the number of missions to be conducted each year, allow other individuals to join in those commercial missions, and eventually develop commercial service providers for our wider Artemis effort. At that point, NASA would just be one buyer of many for lunar landing services. NASA's commercial lunar payload services, called CLPS, uses fixed-price service contracts, not traditional spacecraft development contracts. One important thing to note here is that these lunar missions are the company's missions, not NASA's missions. We've asked industry to ensure a soft landing and be able to operate on the lunar surface. That's two really difficult tasks. Landing on the moon is extremely difficult, and we recognize that success can't be assured. The surface of the moon holds many robotic spacecraft which did not soft land and complete their missions. With CLPS, American companies are using their own engineering and business practices instead of relying on NASA's procedures and oversight to fly their missions to the lunar surface. More than 5 years ago, many in industry were competing to land or to work to land landers on the surface of the moon, competing for the Google X Prize, or they worked with NASA as part of an effort called Lunar Catalyst. American industry more than 5 years ago said they were ready to provide this type of service, and CLPS is a test of that. So we're on the brink of having the first two launches for the first two CLPS landings, and others will follow. To date, the NASA CLPS effort has already generated progress, designing 5 different types of lunar landers, putting into being a chain of high-tech parts suppliers to allow production of lunar landers in the U.S., many of which did not exist before, and also pioneering new technical approaches. We think that NASA's strength in contracting with different CLPS providers for different cargos of NASA payloads is that the companies exhibit different strengths, different approaches, they have different designs, and in some cases using different technologies to land on the moon. Thomas Zurbuchen, the former head of NASA Science, described CLPS using a sports analogy. He said each landing attempt would be like taking a shot on goal. Today, we don't know how many of the early attempts will be successful, but I can tell you that these American companies are technically strong and rigorous, they're business savvy, they're resourceful, and they're driven to be successful. They want to secure that first mover advantage in generating this new lunar economy, and NASA will use that to advance science and technology on the moon. Today, you're going to hear about the first set of NASA scientific payloads headed for the moon on what we expect to be the first launch attempt of Peregrine 1 from Astrobotic Technologies the end of December. This upcoming year is going to be extremely exciting. I'll turn it back over to you.
Thank you so much, Joel. Thanks for kicking us off. We'll now hand it over to Ryan Watkins. Ryan?
Thank you, Nilofer. I'm going to briefly talk about the payloads that we have flying on the Astrobotic Peregrine 1 mission. So Astrobotic has 5 NASA-sponsored payloads that will be making important contributions to lunar science and exploration. This suite of payloads will collect data on the lunar exosphere, volatiles on the lunar surface, as well as the radiation environment, all helping us better prepare for sending crewed missions back to the moon. So just to run quickly through the instruments from NASA that are flying on this Astrobotic mission, we have the Peregrine Ion Trap Mass Spectrometer, or PITMAS, and this instrument will be investigating the lunar exosphere using a compact mass spectrometer. PITMAS will measure the lunar exosphere throughout the course of a lunar day to characterize the release and movement of volatile species of interest to both science and human exploration, so things such as water. And the science results from PITMIS will aim to improve our knowledge of the abundance and behavior of volatiles on the moon and how they respond to perturbations such as rocket exhaust. Of particular note, PITMIS is actually a partnership between NASA's Goddard Space Flight Center, the Open University, and the European Space Agency. So we have some international participation on that one as well. And the payload PI for that is Dr. Barbara Cohen. Next, we have the Neutron Spectrometer System, or NSS. This instrument will measure the number and energy of neutrons present in the lunar surface environment, which can be used to infer the amount of hydrogen present in the environment. So specifically, NSS will measure neutron flux variations with the local lunar time and derive soil hydration and bulk composition by looking at low-energy neutron flux measurements. And the payload PI for that one is Dr. Richard Elphick. Next, we have a Lunar Retroreflector Array, or LRA for short. This is an array of 8 retroreflectors, so think kind of like small mirrors, on a small aluminum support structure. And so the LRA will enable precision laser ranging to help determine the distance from any orbiting or landing spacecraft to the LRA that will be on the lander. So LRA is a passive optical instrument, and it's going to function as a permanent location marker on the moon for decades to come. And the payload PI for LRA is Dr. Zhao Sun. And then we have next is the Near Infrared Volatiles Spectrometer System, or NIRVIS for short. NIRVIS is a suite of sensors that includes a near-infrared spectrometer, a thermal radiometer, and a high-resolution 7-color imager. And so these sensors will make observations of the lunar surface to determine the surface composition, the fine-scale morphology, and the thermal environment. And so NIRVIS will contribute to our understanding of how volatiles may migrate across the lunar surface, including volatiles that could be deposited as part of the lander's engine exhaust, as well as looking at how surface temperatures influence the retention and loss of volatiles. And the PI for that one is Dr. Tony Culbert. And then finally, we have the Linear Energy Transfer Spectrometer, or LETS. This is a radiation monitor that will measure the radiation environment both during lunar cruise and lunar orbit. It will also measure any solar particle events that occur while the instrument is in transit or on the lunar surface. And it will obtain detailed characterization of crew ionizing radiation dosages on the lunar surface, including primary galactic cosmic rays. And the PI for that is Dr. Eddie Simones. So those are our 5 NASA-sponsored payloads. And just to quickly note, I want to share some details about the landing site where they're actually going to be making their measurements. So the landing site for Astrobotic's Peregrine Mission 1 is a Mare region, so a region of ancient basaltic lava flows, named Sinus Viscositatis, or the Bay of Stickiness. And so this name actually alludes to the nearby Gruithuisen domes, which are kind of an enigmatic feature on the lunar surface that's volcanic in nature. And characterizing the emplacement history of these Gruithuisen domes relative to episodes of Mare volcanism is a really important component of understanding the entire history of the region. And so characterizing the emplacement history of the Gruithuisen domes is actually the primary objective of our Lunar Vice instrument suite that's going to fly to the domes later 2026, 2027 timeframe. And so our current Astrobotic payload manifest includes several instruments that are going to take measurements of this Mare region that surrounds the domes that will complement the Lunar Vice measurements. So we've got multispectral measurements of both the Mare and the domes will help us to understand mixing of the materials on the domes. This Lunar Vice suite that will fly later will actually rove to the edge of the domes near the end of their surface operations to take images and measurements of the Mare materials. But having these in-situ measurements from the Astrobotic payloads from the Mare itself will greatly enhance our overall understanding of the invaded Mare deposits. And that's all I have, so thank you, Nilofer. I'll hand it back to you.
Thank you so much, Ryan, for going through some of the science in our landing site. Next up, we have Chris Culbert. Chris?
Thank you, Nilofer. As everybody is aware, the United States has not landed on the moon since the early 70s, more than 50 years ago. We've seen China and more recently India successfully land on the moon in the last decade, but to date, no private company has successfully landed on the moon. Landing on the moon is a daunting technical challenge, particularly for a robotic vehicle. Engines, navigation systems, radios, and many other subsystems all have to work together to enable a soft landing, and they need to do it without human intervention. We've witnessed a lot of robotic landing attempts that didn't get all these systems to work properly, and they ultimately failed. Beyond the technical challenges, there are also significant logistics and management challenges to get all the parts purchased, manufactured, tested, and ultimately built and integrated into a lunar lander. It's one thing for the resources of a national agency such as NASA or Indian Space Agency to be applied to these management challenges, but NASA is asking small commercial companies with a fraction of the size and resources to solve both the technical and management challenges. Over the last 4 years since we've awarded this task order, we've been both pleased and impressed with how Astrobotic and other CLPS vendors have responded to these challenges. They've brought innovative solutions to the table, and we believe they have made reasonable choices about managing risk during the mission. Could they still fail? Sure. Spaceflight's hard, and it's a very unforgiving business. Even small mistakes can have huge consequences. NASA leadership is aware of the risk and has accepted that some of these missions might not succeed. But even if every landing isn't successful, CLPS has already had an impact on the commercial infrastructure needed to establish a lunar economy. We are enabling new supply chains that will benefit the entire aerospace industry. Other agencies such as DoD will have access to thrusters that were previously not available. Traditional aerospace players will be able to buy tanks and other subsystem components from sources that weren't previously available to them. The entire industry will have access to test stands and test facilities that didn't previously exist. These CLPS companies are not just building landers to deliver NASA payloads to the moon. They're bringing their innovative ideas to bids on other DoD projects, on other NASA work. And they're looking and creating commercial opportunities that we couldn't even envision 5 years ago. These companies are now viable partners in the aerospace industry. Even before we achieve our primary goal of landing payloads to the moon, CLPS is succeeding in helping to establish a lunar economy led by American companies. I look forward to Astrobotic's launch attempt next month.
Thank you so much, Chris. So we'll now hand it over to our CLPS provider, Astrobotic, and their CEO, John Thornton. John?
Astrobotic got started to make space accessible to the world 16 years ago. I've been with the company since the very beginning, and to stand at the precipice of our historic first mission is truly awe-inspiring and humbling, and a real testament to all of the hard work of all of the hundreds and even thousands of people that have touched the mission over the years. We actually made our first commercial payload sale for lunar delivery, and I believe it might have been one of the first in the world back in 2014. And since then, we've been collecting payload customers and building up the manifest for this mission that is flying imminently. And we're incredibly excited to have CLPS as part of that. That really was the enabler to make this mission viable and possible. And here we are standing on the precipice of launch. This is our first lunar lander mission scheduled for December 24th launch, and landing is scheduled for January 25th. It's going to be a wild, wild ride. I'm really looking forward to finally getting to space and taking our shot at the moon here. This is going to be the first of many. We're going to be bringing 7 nations to the surface of the moon, 6 of which have not touched down softly on the surface of the moon, including the UK, Mexico, Germany, Hungary, Japan, and the Seychelles. We've got 20 payloads on board this mission, and really it encapsulates the dreams of many thousands of people, between the people at Astrobotic, to our subcontractors, to our payload providers, to our partners at NASA, all together on this one launch. So I know that our engineers have done everything possible to make this a successful mission. We've gone through all of our environmental testing, learned a lot through that, and it's just so exciting. I was just down in Florida a week and a half ago and saw that the vehicle integrated onto the launch vehicle, and so excited that dream is now a reality. So invite all of you to come down December 24th. Yes, it's Christmas Eve, but it will be one heck of a Christmas present, and can't wait for that to get started.
Christmas Eve in Florida. Thank you so much, John. And finally, over to you, Haley. Haley?
This is Haley from Astrobotic. So I joined Astrobotic about 4.5 years ago, right after the 2019 TO2 CLPS award, and started working with our NASA customers and our commercial customers very closely, integrating the payloads onto the spacecraft, designing the interfaces, eventually installing them to the spacecraft, working with all of their teams to get ready for mission operations. And then in the coming weeks, I'll be working directly with all of the NASA and commercial teams in the Mission Operations Center.
Wonderful. Thanks to our briefers for those initial remarks. For awareness, we also have some additional NASA subject matter experts on the line in case there are some specific science investigation and technology demonstration questions that come up. We'll now open it up for questions. And again, if you're on the line, please press *1 to submit a question. Once your name is called, please state your name, affiliation, and to whom you'd like to direct your question. If you find that your question has already been answered, please press *2 to withdraw it. Let's start with Stephen Clark with Ars Technica. Stephen?
John Thornton. You're taking a couple of risks, maybe more than a couple in your view here, but you're flying on the first flight of a new launch vehicle. You're also landing on the moon, which hasn't been done by the United States in 5 decades. In your view, what's the bigger risk, taking a chance on a new rocket or landing on the moon? Can you kind of discuss what the risks are in your mind? Thank you.
Yeah, great question, and certainly one that is keeping all of us up at night and has been for many months and years, really, preparing for this launch. One of the big challenges of what we're attempting here is attempting a launch and landing on the surface of the moon for a fraction of what it would otherwise cost. And with that, we have to strike the right balance of risk and reward. And as you can tell, we did take some risk on the launch going with a new vehicle, but we are comforted with the fact that it is the United Launch Alliance, and they have a really stellar track record of success. The vehicle has a new name, but much of the vehicle is actually the Atlas V, so it's a well-proven vehicle in that sense. Yes, this one's got some new engines and other pieces to it, but we are very confident on that launch. But I can tell you I'll be at the edge of my seat on that launch. Cruise will be a challenge unto itself. Landing on the surface of the moon, of course, has been the biggest challenge that others around the world have faced landing. In only about half of the missions that have gone to the surface of the moon have been successful. So it's certainly a daunting challenge. I mean, I am going to be terrified and thrilled all at once at every stage of this. But I can tell you that every time that we've sent the spacecraft through a test, it's been a test of our program here and our engineers and our partnerships, and a testament even to the payload customers that integrated with us and built great systems. We've passed all those tests. We've done as much as we possibly can here on Earth to ensure mission success. But we are up against one of the most challenging environments known to man. So we'll very excited to finally take our shot here.
Our next question is from Jeff Faust with Space News. Jeff?
Good afternoon, Jeff Faust of Space News. Question both for John and for NASA. I'm curious what sort of lessons learned you've taken during the development of this mission in terms of integrating a suite of science payloads and making sure all the payloads get everything that they need. Any sort of lessons learned from that process that you are applying to future lander missions, either by Astrobotic or other CLPS providers? Thanks.
This is John at Astrobotic. I can start that, and we'll pass things over to NASA. Big picture, we have learned a ton, and we've seen that already with just the progression of Mission 1 to Mission 2. Mission 2, of course, is our second mission to fly to the surface of the moon, which goes in 2024 and delivers NASA's Viper rover to the pole of the moon to drill for water, which will be an incredibly exciting mission. But I can't tell you the number of lessons learned that have come through, from internal processes to material choices and selections to software, to things that we've learned through environmental testing that is passed on to this next campaign, to even robustness of our supply chain, and which vendors are even the best to provide some of these parts. Every one of these missions is a learning opportunity, and I think every time we attempt one of these, we're going to get smarter and smarter. I think of this very similarly to the earliest days of aviation. Early airplanes were not always successful, but it was a movement that could not be stopped. And I think that's where we are here with our lunar missions and the CLPS program. This is a movement where every single one of the vendors is going to get smarter, regardless of outcome, because we will learn from our mistakes or triumphs in either way. We're going to learn how the spacecraft operates. We're going to learn more about the environment. We're going to learn more about our supply chain, and we're going to become more reliable and ultimately a great tool for our nation to return to the surface of the moon.
Okay, hey, thanks, John. This is Chris Culbert. I'll jump in on the NASA side. I guess, a little tongue-in-cheek, my first lesson learned is don't start a program like this during a global pandemic. But other than that, we've obviously learned some things about supply chains and companies' resiliency from that process. The companies are learning a lot about the technical challenges and hurdles they have to get through. On the NASA side, we've got a lot of experience building payloads, so I think we've learned some lessons about the moon, the lunar environment, and getting ready for those missions. We haven't done that in a long time. But in many ways, the most important lessons on the CLPS side have been more in our processes for both defining requirements for these firm fixed price task orders. This is not the normal way NASA contracts for developing lunar vehicles or any type of spacecraft. So we learned a lot of lessons that have more to do with our process and our procurement structure. And that's already reflected in the ways we've changed things over the life of the CLPS task orders. We're up to now 9 task orders, and we learned a lot in that process. We have a lot of confidence the vendors know what they're doing technically. We need to match that on our side to get the administrative and the procurement structure set up in a way that facilitates what they want to do.
Thank you, John and Chris. Another question is from Bill Harwood with CBS.
Yeah, thank you very much, Bill Harwood, CBS News, for John. Thornton, can you explain launch windows a little bit to us, how they cycle around? I realize the rocket's a wild card being a first flight, but just based on your payload, the trajectory and flight plan, how does the launch window change from day to day, and how many opportunities do you think you can get in a row if it comes down to that? And can you provide a few details on the actual descent? I mean, what the flight plan calls for in terms of burns, or what altitude are you at when you start down, those kind of things. Just a few details about getting down to the surface. Thanks.
Sure. Just some big picture comments first. Is the general trajectory of how this goes is we have reserved a flight on the Vulcan launch vehicle that's going to fly December 24th. It's going to take off, I think it's 1:50 something in the morning, so it'll be an early nighttime flight. It's going to lift off and get us directly into what's called translunar injection. So we will be close to Earth, but on a trajectory that will more or less intersect with the moon's orbit. It's at that point, and this is within about an hour or so of launch, we're going to separate from the launch vehicle, and our lander and Astrobotic's mission begins. And at that point, it's our job to communicate to the spacecraft and to make small trajectory correction maneuvers on the way out. So this will be actually the first time we're firing our engines as a system. We've, of course, fired them individually here on Earth, but this is the first time it's been all together as a spacecraft, because you simply can't test that here on Earth. We're going to be doing those maneuvers to A, learn how to fly the spacecraft, and B, make sure that our trajectory is lined up directly with lunar orbit. We'll be doing at least one, likely potentially up to 3 of those trajectory correction maneuvers, and that's dependent on the precision of the initial launch. Now we're going to, when we get close to the moon, and this is a few days later, we're going to descend down into lunar orbit, and we're going to start at a high orbit, and Haley will probably know the numbers better than I will, so she could follow up with some more detail on that. And then we're going to go to a medium orbit and stay in that orbit for a little while we wait for the local lighting conditions to align. So we're actually going to get to the moon in just a few days. Most of the time between launch and landing is actually waiting for the local lighting to be correct. So basically we're trying to land at a specific spot on the moon at a specific time, i.e. morning at this location near the Grundheisen domes. And because of that, we have to wait for the moon to rotate all the way around so that sunrise is happening while we're landing. So that's why there's a gap. And then we will descend down to our lowest orbit. We'll stay the least amount of time in that orbit. and then start our descent down to the surface. And that last final phase, that will be the real nail-biting, wild event that we'll be witnessing live here in Pittsburgh at Mission Control Pittsburgh at Astrobotic. And that will be fully autonomous descent down to the surface of the moon, and we'll be getting all of that data back live. And hopefully, if all goes well, a massive celebration down here on Earth as we transmit landing successful. At that point, we're going to be doing checkouts of the spacecraft, making sure everything's safe, and then we're going to turn the spacecraft payloads on one by one and begin the payload missions. And Haley, maybe you could add some color to some numbers on that.
In terms of the
start with the orbit altitudes and any loitering times.
We'll have 3 lunar orbits. The first is Lunar Orbit 1, which is about approximately 9,000 kilometers by 100 kilometers. And then Lunar Orbit 2, which is our parking orbit, which is approximately 750 kilometers by 100 kilometers. And then our third orbit, Lunar Orbit 3, is 100 kilometers by 100 kilometers, and that's the orbit from which we'll start our descent sequence.
Thank you, John and Haley, for that. Next up, we have Marcia Dunn with the Associated Press. Marcia?
Yes, hi. For John Thornton again. Do you see yourself as being in competition with intuitive machines? You guys are nose to nose in your race to get to the moon. Do you have bets? What's your relationship with them? How long do you expect your lander and its payloads to be working on the moon? I'm not sure if it's a 2-week period or more. And lastly, do you have anything personal going to the moon for you, for your employers, or even for your city, Pittsburgh, which, by the way, is my hometown, I must tell you. So thanks.
Awesome. Thank you for that question. Starting from the, what was the first question? I'm sorry. It's intuitive machines, right? So big picture, we are trying to create a movement of commercial deliveries to the surface of the moon. The most important and top priority of that is the industry's success. That's Astrobotic's position since day one, is that we need this industry to succeed. We need this CLPS program to succeed. That is the number one priority for us. Of course, there is also some level of competition with our competitors, but at the end of the day, it's really secondary. The most important is the industry, and the most important is landing success. So I actually spend most time talking about and thinking about our competitors when the press asks me, rather than day to day, because right now we are just laser focused on a successful delivery and a successful mission, because that matters more than anything else. That's going to carry us to the next mission and make the business successful. On to the next question, which was about the length and duration of payload operations. So the way this works is we're waiting for the local sunrise to be just right, and then we're going to land, touchdown, deploy our payloads. We're going to operate for about 10 days, and the reason for that operational window is in about 10 days after landing, we expect the sun to set. And when the sun sets at our location, temperatures will plummet. So it'll go from a relatively warm 100 to 120 degrees Celsius down to liquid nitrogen cold, and it will stay that way for 2 weeks. And typically with temperatures in that range, there's lots of things that break. Battery chemistries aren't happy with that. We get coefficient of thermal expansion differences between materials, say a copper and an aluminum. You can get a solder joint break. Basically, we expect the spacecraft to have some problems through that night and probably not be able to survive. That's what history tells us with lunar missions on the surface. In time, we are developing the capability to survive that night, but on these first missions, we're really focused on the hard enough problem, which is landing on the moon in the first place. And then to the last question I'll start first with Pittsburgh and what this means for the city. For Pittsburgh, space is new, and the moon is new. If you go to any kind of social event here in Pittsburgh and you say you work in space, people are like, what? It's different in different parts of the country. If you're in Houston or if you're in San Francisco or LA or Florida, you probably know someone who knows someone who's in the space industry. But here in Pittsburgh, it's new. It's a totally foreign idea. And for us, that's an opportunity. It's an opportunity to show a whole region a window into an exciting $480 billion industry, and an opportunity for our region's youth and our region's next generation to get involved and excited, and our lawmakers and supporters to help encourage and build the space program nationwide. So I think it's a real honor to be that flagship mission from the city of Pittsburgh. And it's to me, it's also, I think, an exclamation point on the transformation of the city, one that started in steel and glass at the turn of the century, fell upon hard times, and has rebuilt itself into a tech and med hub. And now we're going to be big exclamation point on now Pittsburgh will be going back to the surface of the moon and taking our nation with it. So if Pittsburgh can land on the moon, Pittsburgh can do anything. So to mark that as part of our mission to the moon, we have a plate going to the surface of the moon that has all of our employees' signatures on it. We also held a contest in Pittsburgh about what of Pittsburgh we will send. There were all kinds of submissions to that, like a piece of the terrible towel from the Pittsburgh Steelers. And there was also songs from Mr. Rogers' Neighborhood that was put up as an option. There was another option of so I don't know how this would work, but a sandwich from Permanis. But the thing that won actually is a token from Kennywood, and Kennywood is our local amusement park that's super popular here. So that is the token of Pittsburgh that's going to go on this very first mission. But what I can tell you is that the hopes and dreams of Pittsburgh ride with this mission. I can't tell you how excited the local community is here. We just had the governor and the mayor of our city and state here. This really means a lot to the people of Pittsburgh and the people of the Commonwealth. This is a state that is not used to leading in space, having an opportunity to lead in space and make a historic moment.
Thank you so much, John. So as a reminder, today's briefing is on NASA's Commercial Lunar Payload Services, or CLPS initiative, where we aim to address the significance of this CLPS flight and highlight the NASA-provided payloads flying aboard Astrobotic's Peregrine lunar lander with Peregrine Mission 1. Our next question is from Gina Sinceri with ABC News. Gina?
Thank you. What is the significance of the name Peregrine, and how do you see your two missions working together?
So this is John at Astrobotic. Peregrine is the fastest flying bird on Earth, and we thought that would be an appropriate name for a lander flying down to the surface of the moon. It does involve incredible speeds to make that happen, to get out to the surface. So we thought it was an appropriate name for the lander. And the partnership I'm very excited about with NASA, because this is truly enabling our nation's scientists to access the moon in a fundamentally different way. We're going to see routine, regular flights of smaller scale, but more routine and opportunistic ability to sample surfaces of the moon, to discover and explore things about the moon that we've never been able to do before. And it's at a cadence that just isn't traditional in space science. Oftentimes, if you're a lunar scientist, you might have to wait your entire career to have one opportunity to fly an instrument on a planetary mission. CLPS and this partnership with NASA affords the opportunity for our nation's scientists to regularly touch the surface of the moon multiple times in their careers and have a campaign of tests and results. And that really opens up the aperture and the opportunity for learning, for discovery, and ultimately for development and utilization of our nearest neighbor.
Thank you, John. Next up, we have Chris Davenport with Washington Post. Chris, your line is open.
Thanks so much. I guess this question is for John. If you do launch on the 24th as expected, what's the timing of the landing? I mean, when do you expect to touch down, if you have a date or a time in mind? But it also, I guess, sounds like the final descent down to the lunar surface is going to be a call that perhaps is made in real time, waiting for the sun to be right. And if that's the case, how far advance of the landing would you make that call? Thanks.
Yeah, good question. So our initial launch window is December 24th at around 1:50-ish a.m. And we do have a subsequent window on the 25th and 26th. All three of those launch days coincide with a January 25th landing. And basically all we do to change is change how long we loiter in orbit. So that landing time and date is fixed the moment that we launch. And that is because all of our sensors and all of the mission profile is set up to land at a specific site at a specific time to be successful for our payloads.
Thank you. Next up, we have Lucy Alborg with AFP. Lucy, your mic is open.
Hi, thanks for taking my question for John Thornton again. Were you able to draw any conclusion or learn anything from the failures of other companies like iSpace?
Luckily, we have. iSpace in particular was very generous in sharing what occurred with their mission. They were fairly public with that with the world. And I think that's just a perfect example of what we're really up against. This really is humanity against our most challenging environment, the space environment. So we were able to learn from that. We were also able to learn a little bit from India and Israel as well, just seeing what was out in the public sphere. So we've certainly taken a look at those same scenarios with our lander, and we don't anticipate those to be issues because of those heads up. Point being, collectively, as a species, the more we go after the moon, the more launches we see, the smarter we will get. And certainly, the U.S. and CLPS has a huge leg up in the cadence and number of missions that are really going to open up the opportunity to learn and get better and better and better.
Thank you, John. Now we have Will Robinson-Smith from Spaceflight Now. Will?
Yes, hi. Thanks for taking our questions this afternoon. Question, I suppose, for Ryan or Chris, and perhaps John, if you'd like to weigh in as well. There were, as I understand it, 5 payloads that were originally going to be flying on this mission from NASA that were reallocated for future CLPS missions. I was wondering if you could talk a little bit about why those ones were punted to later flights and how the NASA selected payloads were narrowed down to the 5 that are in fact flying next month. Thanks.
Sure, this is Chris. I'll take that one. What we've learned, as we watch these lander systems being developed, that for the most part there were not available commercial engines with the right mix of performance and cost that would be matched to the size of the lander being developed by companies like Astrobotic. So that meant that a lot of the CLPS vendors, not just Astrobotic, are planning to use engine designs that are new. But not surprisingly, new technology has some risk associated with it, and it doesn't always work as advertised in the first iteration. So while we were working through that process, we had lots of discussions with Astrobotic. Rather than delay this mission further to wait on additional engine development, we worked with Astrobotic to agree on getting the most important payloads as we could to deliver as early as possible. And a lot of that was guided by Astrobotic's process to maintain center of gravity and moments of inertia on the lander. Because we'd already designed the lander, we'd put the payloads on there. But we did jointly agree to demanifest a handful of payloads from the first mission to enable that first mission to be more likely to succeed. And we will remanifest all those payloads onto future CLPS flights. So we'll still get the benefits from all those instruments.
Thank you, Chris. Another question is from Russell Towns with Pacific Rim Media. Russell, your line is open.
Good morning. Thanks for taking my call. I'm calling from Alaska today, and this question's for John. How old were you when you first started thinking about space? And as a follow-up, in what part of your presentations does the public or your investors have the aha that this might be a meaningful effort? Thanks.
Thank you for the question, and a real pleasure to hear from you from Alaska. So I actually, my first spark, it's a funny thing. Almost everybody in space can tell you when they were sparked to be inspired to get in the space industry. For an entire generation, it was Apollo. For my generation, I grew up in the 80s. For me, it was when the the Mars lander, Pathfinder, and rover Pathfinder landed on Mars for the very first time. I was, I think, in the 5th grade at the time, and my teacher at the time had this open-ended project, and I picked the Martian landing, and I got to build a Lego model of the Mars Pathfinder, and I read every article I could find about the mission, including like looking at all the 3D images, the red-blue glasses. So that for me, that's where space was sparked. And decades later, here we are, and 16 years into my career, my entire career. Here we are with our first moon attempt coming up. So incredibly exciting and quite thrilling to be a part of that. But we hope to do that for the next generation as well, have that same spark moment and inspiration moment. And to that, every moment of our build here at Astrobotic, as we build the lander, as we integrate NASA's payloads and all the payloads from the rest of the world here, that has all been viewable through our glass window wall from what we call the Moonshot Museum, which was a nonprofit that Astrobotics helped stand up and spin out. They now operate a museum right on the other side of our glass window wall, and they can look in and witness the build of our landers, as well as experience some very cool space things inside the museum itself about the future of the moon. And we do that at Astrobotic for the very core purpose of making space accessible to the world, because we want to have more kids of the next generation have the same inspirational moments that I did to get into where we are today, for hopefully our missions. And I hope that the kids and next generation of Pittsburgh will see this mission and be inspired themselves to follow their dreams, whether it's going into space or going into engineering or any other field. I mean, Apollo did the exact same thing for an entire generation that inspired folks to go into all different technical fields. We're hoping that we can be a small microcosm for the Pittsburgh region for that next generation here in town.
Great, thank you. Another question we have is from Alexandra Witz with Nature Magazine. Alexandra, your mic is open.
Yeah, hi, thanks. It's Alex with Nature. This is for Ryan Watkins. And going back to this question of what's not actually on this flight, some of those payloads that are getting remanifested for future flights are some of the key scientific observations that have been talked about by NASA since the very early days of the CLPS program. What science is getting lost by pushing those a little bit later, and how are you ensuring that kind of the evolution of scientific understanding and the gathering of measurements that you need throughout Artemis is happening in kind of the right order in the CLPS program?
Yeah, thanks for that question. So, like you said, there were a few payloads we had to pull off of this particular manifest. Just for some history, the landing site for TO2AB, the original landing site that we picked did not have as high of an expected science return. So that's one reason that we moved it over to Sinus Viscosatus. But when we had to pull those payloads, we kind of did so in a way to ensure that we had payloads that could take the best kinds of measurements at the landing site we were going to. That's not to say that the other payloads that we had to pull off aren't taking important scientific measurements. And like I think it was either Chris or Joel mentioned, we do plan to refly all of those payloads on future manifests. Currently working on filling those locations at the moment. So we're not losing any of that science. It is being slightly delayed because they will fly later. But we will, make sure that we fly them to landing sites where they can get the best science for their instruments. And as you mentioned, science that can also inform Artemis, but also that can stand alone from Artemis as well, because there's, science investigations across the surface of the moon that are important for a lot of different reasons that, may or may not always be related to human exploration. I don't know if anyone else wants to jump in to help answer that, but again, we are committed to flying those payloads and making sure that we can get the most science out of them on those future flights.
Thank you, Ryan. Next up, we have Stephen Clark with Ars Technica. Stephen?
Thanks for taking another question from me. This is probably for John or Haley again. A couple of questions. If you don't get off the ground by December the 26th, when in January would be your next launch date, and do those come in lunar cycles about every 4 weeks or every 2 weeks? How are those spaced out? And also, assuming you do launch the 24th, 25th, or 26th, you mentioned the landing date would be January the 25th. What would be the date that you actually enter orbit around the moon when you're captured? Thanks.
On that first question, we're unable to give you more dates on our launches. We know what they are. We just can't share them at the moment, unfortunately. So we'll follow up if in the event that we need those dates to come up. And then in terms of when do we get into orbit, I'm seeing some data here that says on order of about 12 days from Earth to orbit.
And that was our last question for this afternoon. Thanks to all of you who submitted questions, and thanks to today's briefers for taking the time to discuss NASA's CLPS initiative and Astrobotic's upcoming Peregrine Mission 1. As a reminder, Astrobotic is scheduled to launch aboard ULA's Vulcan rocket no earlier than December 24th, 2023. Thank you again for joining us. A recording of this briefing will be available on nasa.gov/CLPS. That will wrap us up for today. Thank you.